Wait.
Okay.
Are we starting?
Yes. Okay, so the first one we had is sine, and I'm going to label it right here so I know. And oh, it's still not up there. Okay, let me. I'm sorry. I thought I told it to. Okay, so the first one we worked on was sine. Come on, let's go. And on the bottom, I did make a mistake. I should have written this stuff in red, but this is all for sine that we've done. I usually try to write it in the same color. Okay, so what is the reciprocal of sine? No, cosecant. Okay, so we're going to take our main points again, and we're going to reciprocate them. Okay? So if I reciprocate 0, what is that?
0.
No. It's undefined because 0 over 4 is 0, yes? And the reciprocal of that is 4 over 0, which is undefined. So that makes it a what? First cosecant. An asymptote. So anytime that sine is a 0, cosecant has a what? Asymptote? So how far apart are these curves going to be? Because it's obviously not continuous, right? What is the distance between these asymptotes? Pi. Is that something we already had?
Yeah.
On tangent, wasn't it? Okay. Well, what's the reciprocal of 1? 1. Okay. What's the reciprocal of -1? -1. So all of these are here, right? Well, we talked about pi over 6, which would be like right here, wouldn't it? Because this would be pi over 4, so this would be like pi over 6. Well, the sine of pi over 6, which is 30 degrees, is 1/2. So what's the reciprocal of 1/2? 2. So all of these are little parabolas that come down and bounce off and come up and bounce off. So if you know what sine looks like, do you have to do much to get cosecant? So right here is cosecant. Well, does it have a y-intercept? No. Does it have an x-intercept? Does it touch the x-axis ever? Yep. So y and x-intercept is none. What's its domain? Can't have any of the asymptotes in it, right? So where are those asymptotes at? Pi, 2 pi, 3 pi, 4 pi, 5 pi. What? All the whole pi's. So how did we do that? We just said plus or minus pi n. Right. So x cannot equal plus or minus pi n.
Did you put after x-intercept?
I put 1.
I was like, is that
And that looked like a square. I had to finish it. I don't know why I didn't put the n in front. What about range? This might be a tricky one. Does it use all the y's? Comes down to 1 and bounces off. Comes up to -1 and bounces off. So it doesn't use anything in here, does it?
So it can equal 1 to -1.
So will you just say y is less than equal to -1 or y is greater than equal to 1? Is it continuous?
Yes.
No.
It has asymptotes in it. It's not continuous. Okay. Something else I want to talk about, and we're going to do it on all of them today, and we didn't do it before. These graphs have a period, a cycle. We talked about it being cyclical, right? It starts over. It repeats itself. So if I start at 0, I have all the positive answers here, and then I have all the negative answers here, and then what would happen on the next section? It would go positive again, right? So I got negative, positive, negative, positive. So I need more than one of these, correct, to get everything? So I need 1 pi. I need how far? 2 pi? Could that 2 pi be from negative pi to positive pi? Could it be in here? Yeah. Could it be here? Yeah. Any consecutive. So the period is 2 pi.
Can you move the sheet up?
Period is 2 pi. An amplitude is the distance, like it goes up or down. The max. Well, if it goes forever up and it goes forever down, does it ever have a destination it gets to? No. Some people will say infinity. I have a problem with that because we don't define infinity as a number, do we? No. I usually say it doesn't have an amp. But then when I say it doesn't have an amp, what do you think of then? You think of something that goes up and down or something flat? Flat. But it does. So I'm going to let you guys, what do you think? You want to call it an infinite amplitude? Okay. And it's like plus and minus, yes? Goes to both? Okay. So now let's come do this for sine then. It's neither. It's a neither. And this is why one section of it is even because it starts up. One section's also even, but when you put them together, it's not. It's kind of one of those neither. We don't really talk about it. We don't talk about it. Yeah. And technically, in the sense of being the same forward or backward, we would say it's odd in that sense because it's the opposite values. Okay, so let's do period of sine and amplitude. Okay, so the period is the distance on the graph it takes to start repeating itself. So I'm going to start at 0. You tell me when to stop. Stop. How far was that on the graph? 2 pi. I'm going to start at negative pi, and you're going to tell me when to stop. How far is that from negative pi to pi? 2 pi. I'm going to stop at negative pi over 2, and you're going to tell me when to stop.
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 Okay, how far is it from 3 pi over 2 to negative pi over 2? 2 pi. The period is 2 pi. Didn't matter where I started it, it came out as 2 pi. So again, the amp is the distance from the axis of the curve. The axis of a curve, we've talked about it before, is in the middle. Yes? So this graph goes up how much? Down how much? Okay. But distance, is it ever negative? No. So it goes up 1 unit and down 1 unit. The amp is 1. Okay, so there's sine and cosecant. This was all cosine information that we've written, right? Okay, so the same thing is going to happen. Every 0 is going to become a what? Asymptote. So every 0 make an asymptote. And every positive or negative 1, it's just going to be positive or negative 1, right? What do you notice about the sine and cosine graph, guys?
It's the same thing.
It's
just
just,
moved over.
it is. It's the same thing shifted over. And then we're going to reflect off of those. So technically, sine and cosine are the same graphs, just translated. So when we start writing equations, you will write every equation for both sine and cosine, because it would just be a different translation. It's a pi over 2 translation, isn't it? Does yours look like that? Almost. Layden, does yours look like mine?
Yeah.
Yeah?
Close enough.
Close enough. It's about as close as you're going to get, right? So this red is secant. So x and y intercept. Do we have one? Be careful. Doesn't have an x-intercept, but does have a y-intercept. Yep. Y-intercept at 0, 1. But no x-intercept. And that's only because of that translation over, isn't it? Okay. Domain. Where are my asymptotes this time? The pi over 2, right? Pi over 2, 3 pi over 2. So we start with the first one. So x cannot equal pi over 2. And how far is pi over 2 from 3 pi over 2? From negative pi over 2. From negative. How far are those all apart?
Half pi. Or
Not a half pi, a whole pi?
1 pi.
Yeah. So plus or minus pi n? I get to what you mean in like you, but it's 3 pi over 2 minus 1 pi over 2 is going to be 2 pi over 2. What about its range?
the same as
Cosecant?
cosecant?
Yep, it is the same as cosecant. So y is greater than equal to 1 or y is less than equal to 1? Because it's nothing in this middle part, is it? Period. What?
Y is less than or equal to -1?
Oh, yes. That should be a -1. I was trying to squeeze it in and I didn't. Yes. Okay, so period. How far does it take to get both pieces, the positive and the negative? Well, let's see. 3 pi over 2 to 2 pi, right? And that is 2 pi? I said 2 pi, pi over 2. I could go from 0. Here's half of the positives, but here's the other half of the positives, right? And how far is that? 0 to 2 pi. So can we cut the period in different places? Yep. So the period is 2 pi. And the amplitude is positive and negative infinity. Actually, we can't go negative. And it's just positive infinity. And I did that wrong. Because up here, remember I said it can't be -1. And I put that negative on the amplitude for cosecant. I'm sorry, guys. I apologize. I know. So let's do period and amp for cosine then. So what's the period of cosine? How long does it take to start and stop? Or repeat itself, maybe.
2 pi.
2 pi. And if sine and cosine are basically the same graphs, that should be the same, right? And the amplitude is the distance from the axis to the max and to the min is 1. Now, when we do our H and K and move it all around like we've done with every other graph I've introduced to you, we are only going to do it to sine and cosine. But you do need to know what the parent functions for secant, cosecant, tangent, and cotangent look like. Okay? Okay, so tangent, let's go ahead and add, this is all, tangent is green. Let's go ahead and add period and amp before we start, just because. How much of this graph do I need to get all of the behavior? No, just like how I'm going to start here. Where does it start repeating? Aren't all these individual curves the whole graph, all of the behavior? So how far is that? From negative pi over 2 to, it's pi. And the amp then, is that infinity? Because it goes forever in both directions, correct? Okay. So now let's do cotangent. Well, all the zeros become what? Asymptotes, right? Can you guys see that red? No, nobody's yelling no, so kinda.
No.
Do I need to switch? Just feels very light to me. I don't know if that's any better.
Better.
It is? Until it decides to run out.
Yeah.
getting that time of year. Anybody wants a bunch of orange ones, you can have them because I can't use them on the project. You can't see them. Well, the deep orange, yeah, you can't really see it. Okay, you got all your asymptotes on there? Hopefully that's better. Okay, so when I reciprocate, what ones did we put on there? 1, a -1, right? Is that what we put on there? So when we reciprocate -1, we get -1, don't we? When we reciprocate 1, we get 1. So all these points they have in common. But it's not going to be the same graph because of what? The asymptotes. So it's not going to increase. It's going to... Oh, all the asymptotes become what now? Zeros, don't they? Forgot that. Because the reciprocal of undefined is 0. Okay? So we're not going to increase, we're going to decrease. It always reminds me of DNA for some reason. I don't know why. Kind of pretty. So the pink is cotangent. Or my pink, whatever yours is. Do I have a y-intercept? Nope, no y-intercept. Do you have an x-intercept? Zero. Well, no, that would be pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So I have an x-intercept at pi over 2 plus or minus pi n, comma 0. It's a weird way to write it, but are there multiple x-intercepts? Yes. Okay. Domain. What's not included in this one? Matt, what's not included? So where the asymptotes are, correct? Where are those asymptotes at? The whole pies, right? 0, 1, 2, 3. So just plus or minus pi n. Range. Are all the y's included? Yep. So all real numbers. It would be considered an odd function as well. Period. And amp. How much of the x-axis do I need to see all the behavior? Pi. And the amp is infinity. Now I will tell you, if you go to a book and they show you this function, they show it to you as one period, and I'm actually going to show you tangent. they showed it to you, like I showed it to you like this, right? This is like what we talked about because it's one continuous. They show it to you like this. And they don't have both together. But do I have the positive piece and the negative piece? Yep. I don't like how I did that tangent. It's what's bugging me. I don't know. It's because it's so spread out. Okay, so that's it for your notes. So in your assignment today, it's going to ask you to say where. Let me see. How do I want to phrase that? Oh, I am going to show you. If you go to the textbook and look, this is how they show them. There's sine and cosine. Is that what yours look like? Okay, that's one period. There is tangent and cotangent. Remember, I told you they would show it differently. They'd show it broke up. And then there is cosecant and secant. And if you imagine cosecant, if you imagine that sine wave right here, can you do that? And the cosine wave here. So that's that cutout part. In your assignment, you start at 13.
So
And
come on, here you have till 34. So are we going to 34 or 43?
$34. But it wants you to use your graph that we made. And it says use the graphs you made in problem 1. Okay, they're already there. 1 through 6. Find all the values between 0 and 2 pi where cosine is 0. So you're going to take your graph, and between 0 and 2 pi, where is cosine 0 at? No. Cosine. You're on sine.
Mm-hmm.
Where's cosine 0 at? Pi over 2 and 3 pi over 2. Should you be able to do that without looking at your graph? Aren't those values you should know? Yeah. Okay, but we're just getting used to looking at the graphs. So that's what you're going to be using is your graphs that we made over the last 2 days. We basically did problem 1 through 6 together.